Hello guys, it's Miss Garcia. Welcome to Math City with Miss G. In this video, we are going to talk about 45, 45, 90 degree special right triangle. Before we are going to start with the actual topic, we are going to make a connection between the previous topic, Pythagorean theorem, and finding the missing side of the figure that we are looking at on the screen. Let's focus on the given angles. So we have here two angles that measures 45 degrees. So when these two angles are 45 degrees, then therefore we are dealing with an isosceles right triangle, which means that the base or the legs, these two sides right here are considered legs. So I'm going to label it with leg. These legs are going to be equal to each other. So therefore, the B and the bottom is going to be equal to 5. Now, our goal is to find C. How do we find the value of C? So we're going to use Pythagorean theorem in doing that. So that is A squared plus B squared equals C squared. So we'll do 5 squared plus 5 squared equals C squared. 25 plus 25 equals C squared. Adding these two together, that makes 50 equals C squared. We want to get the C by itself. So we're going to extract the square root on both sides. And if you focus on the number that we have right now, we have square root of 50. Let's split 50 wherein one of the factor is going to be a perfect square number. What would that numbers be? So if you're thinking of 25 times 2, you are right. Why do we select 25 and 2? Because we want one of the factors to be a perfect square. What makes 25 a perfect square? It is because 5 times 5 is equal to 25. That makes it a perfect square. Or 5 squared is equal to 25. Now, we're gonna attach the square root symbol that goes with it. Equals this, it will be equal to C. The square root symbol goes away together with the exponent of C. And so, the answer that we have right now, if we are going to focus on this section, we can split 25, square root of 25 with square root of 2 equals C. So square root of 25 is a perfect square, which is equal to 5. Square root of 2 is not a perfect square, so we're just going to drop down square root of 2 equals C. Therefore, the value of C is 5 square root of 2. We're going to write that answer right here. So 5 square root of 2. So let us focus our attention to the answer that we have right here. So notice that the leg's measurement is 5, and there is something that is common with the leg and something in the hypotenuse. So notice there is also a 5 in the hypotenuse or the value of C. So in case we are trying to find the value of C or the hypotenuse in a 45, 45, 90 degree right triangle, then we can use a formula. And that formula would be H, which stands for hypotenuse, equals, take the leg, times square root of 2. So this is one of the formulas that we are going to remember. I'm going to highlight this portion right here. So then when I am solving for hypotenuse, in a 45, 45, 90 degrees, I will just take the leg, if leg is given, times square root of 2. Let's use this information to answer these two triangles right here. Using that information we just talked about earlier, we've got here this tick mark, which means that these two sides are equal. So then therefore, this side is going to be 6. That makes this triangle a 45, 45, 90 degree right triangle. And so therefore, the hypotenuse is going to be the leg, which is 6, times square root of 2. Let's try that on the other side of the triangle. So we have 45 and 45-degree triangle with the box, which means 90. So then therefore these two are going to be equal to each other, as we see that they're exactly the same x. So the hypotenuse measurement is going to be the measure of the leg, which is x. We're going to attach that square root of 2 in the leg. So x square root of 2 is the measurement of the hypotenuse. So let us try and answer these two problems. But before that, let's write what we just did earlier. So this was x, and this is x, and we our hypotenuse, if the two legs or each of the legs are x, we'll have x squared of 2. Leg is x, hypotenuse is x squared of 2. By the way, what makes 45, 45, 90-degree right triangle a special right triangle? It is because the ratio, if you have noticed, is equal to 1 is to 1 is to square root of 2. So notice that we have here an x, and you've got an x, which is the coefficient of the x squared of 2. So that makes this type of triangle special. All right, let's use that information to try and answer these two problems. Find the value of the missing variable. So we have an indication that this is a 45, 45, 90 degrees. So that's first thing we need to figure out. Now that we know that, so then therefore these two are going to be the same. X is 8 and y is going to be 8 square root of 2. Number 2. We are given with the side, the leg. So this is 25, and we've got 45 right here. So this is also 45-degree angle. So then that leg is going to be equal to this leg, which makes 25. And the x is going to be 25 square root of 2. Let's try a problem that looks like this. Now, one of the leg is missing. Remember the formula that we used earlier that was to find the hypotenuse. We take the leg and we multiply it by square root of 2. This time, we are trying to find the leg. How do we find the leg? So we are going to use that exact formula. We're trying to find the leg, right? We're going to divide this by square root of 2. We're going to divide this by square root of 2. And we're going to cancel this. And that will make us find the leg. So meaning the formula to find the leg is simply take the given hypotenuse and divide it by square root of 2. So this is the second formula we are going to remember, or we just go back to the initial formula that we come up with. Hypotenuse equals leg times square root of 2. So I'm going to highlight these because this is one of the formulas that will help me find the leg of a 45, 45, 90-degree triangle. Okay, so let's follow this step. Let's say I am going to use x or y because these two are exactly the same. So x is equal to, the hypotenuse is 19 over square root of 2. Now, here's the thing. If there is a radical, I'm referring to this symbol. So this symbol is called radical. If there is a radical in the denominator, that means we need to do something. And that something is called rationalize. Rationalize meaning we're going to get rid of the radical number that's in the denominator. So what do? We're going to take that exact number, square root of 2. We're multiplying that on the top, in the numerator, and in the denominator. So we're basically multiplying with a 1, but it is in a form of square root of 2 over square root of 2. Remember, if I have a 4 divided by 4, that's equal to 1. If I have an x divided by x, that's equals 1. That's the same concept. Now, let's simplify. I will have 19 square root of 2. We can't combine these two. We're just going to bring over 19. We bring over square root of 2 just like a variable. The bottom or the denominator is going to be square root of 4. Now, that square root of 4 can be simplified. So then, therefore, the x value is going to be 19 square root of 2 over 2. Because square root of 4 can be simplified into 2. So the x value is equal to 19 square root of 2 as well as y. So 19 square root of 2 over 2. So both of them has exactly the same measurement. Hopefully you have found value in this video. Thank you so much for watching. I'll see you in my next one. Bye.